Hey everybody, so we have another video talking about irrational zeros. This is just another example. So they say list all possible rational zeros, then find all the real zeros. So they want us to write out all the factors of 60 divided by all the factors of positive 1. Now, since this happens to be 1, we don't really have to do that because anything divided by 1 is itself. So all we really need to do is just write out our factors of 60. So that would be, let's see, if we want all possible zeros, so while this list is quite expansive, remember that the benefit of doing your rational root theorem is because without the use of a calculator, the possibilities for this, they almost seem infinite. But with the rational root theorem, we can narrow it down to just these options here. Now, we're not going to go through and plug in all of these and test them into this polynomial. We're going to use the calculator, and all we really need to do is find one possible zero. So let's go to our calculator here. We'll go to y equals, and we'll type in our equation. So here's my equation typed in. I'll look at the graph, and I can see that all of these are going to be my zeros. So for the purpose of this, we only need to use one of these, so we can use this one here or this one. We can't use these two in the middle because we don't know what those values are. So if I hit second graph, I'm just going to use this one here, 4, 0. So because the y value is 0, that means that's where the polynomial would cross the x-axis. So if I know that positive 4 is a solution, then I could use synthetic substitution and evaluate this polynomial to find what my remaining factor would be. So remember, with synthetic division, you start with your leading coefficients. So I should use 1, 1, negative 23, negative 3, and positive 60. So 1 comes down, now we multiply. 4 times 1 is 4. Here we'll add. We get 5. 4 times 5 is 20. We'll add again. We'll multiply. We'll add. Now remember, you want this to be 0 because that proves that this is a root. We already know that because of the calculator. But if we didn't have one, that's how you would know when one of these factors is a solution here. So if we know that 4 is a root, then we know that x minus 4 is a factor. And the remaining factor will be this. So here, remember that when you start with synthetic division, up here we started with an exponent of 4 and then 3 and then 2. So this solution will reduce there. So that would be your x cubed, your x squared, your x, and then your constant. So this would be x to the third plus 5x squared minus 3x minus 15. So since this has 4 terms, one of the easiest and most convenient ways to factor here would be to use factor by grouping. So I'll leave this x minus 4 alone, and I'll just do the factor by grouping here, and I'll just offset it in these brackets. So I'll group the first two, and the last two. So inside the brackets, what I'm going to be doing is in each of these parentheses, these binomials, I'm going to pull out the greatest common factor. So it looks to be an x squared here, which would leave me with x plus 5. And then I could factor out a negative 3, and that would leave me with x plus 5. So my factors are going to be x minus 4, x plus 5, and x squared minus 3. Now remember, they wanted you to find all the zeros. So what we need to do is take each factor here and then set it equal to 0. So this would be x minus 4 equals 0. x plus 5 equals 0, and x squared minus 3 equals 0. So I'll just do a little line here just to have some separation. So my solutions are going to be x equals 4, x equals negative 5, and this is going to be x equals plus or minus the square root of 3. Remember, we had to add 3 to the other side, and because this is squared, we had to solve by taking the square root. All right, that's going to be it for this example. I hope you found it helpful. If you have any questions, please be sure to leave them in the comments.